For that purpose, nature has provided them with tough antlers, made of bone. Despite energetic wrestling, broken antlers are very rare. But bone is heavy, so nature is as economical as possible. Inside, bones are partly hollow, but filled with a complex network of arches and spans. This beautiful hidden structure is also elegant engineering. The bony struts are laid down along lines of stress in the bone, so it's strongest where it feels the biggest loads. It's as strong as it can be, but using the minimum of material. Even our own skeletons can be a source of inspiration. The human thigh bone, or femur, is especially elegant. The head of the bone is off to one side, which means the weight of the body has to be transferred, first sideways, then down the length of the bone. Struts of bone arch through the head of the femur, transferring this weight both effectively and economically. And architects realized they could apply exactly these principles in constructing tall buildings. It's the inspiration behind one of the most famous buildings in the world, the Eiffel Tower. Gustav Eiffel used the structure of the human thigh bone in building his 300-meter tower, the tallest building in the world until 1930. Like the curve in the head of the femur, the famous iron curves of the Eiffel Tower are supported by a latticework of metal struts and girders that transfer the tower's weight sideways and down to the ground, just as elegantly as the internal struts of bone. In recent years, more and more designers and engineers are looking at the way nature builds bodies and getting inspiration for everything from new bridges and buildings to cars. Cars need to be tough, but can't be too heavy or they burn too much fuel. Nature faces the same problem, which is why both animals and plants only lay down material precisely where they need it. So this car-shaped fish, the boxfish, might be a good model for an economic car. And when the engineers at Daimler Chrysler designed a chassis using a computer program that, like the boxfish, laid down more material where the loads were greatest, they found they'd made their lightest, strongest chassis ever.